that is a very favorite question of your GATE for your GATE exam. Now I will take a single question in which there are 4, 5, 6 objective questions of the previous year GATE exam and the expected GATE questions that can be completed. Okay, in your GATE exam they will ask only one single factor for 2 marks. Okay, so read the question. On a particular day, the atmospheric air was found to be a dry bulb temperature of 30 degrees Celsius and the wet bulb temperature of 18 degrees Celsius. Okay, dry bulb temperature is this, wet bulb temperature is this. Now the barometric pressure was observed to be 756 mm of mercury head. Okay, 756 mm of mercury head. Now using the psychrometric properties of the air, determine the relative humidity, specific humidity, dew point temperature, enthalpy, and there are so many factors. I will discuss all the things, okay, in detail, so don't worry about that. So now in this case, the temperatures values are given. Okay, the temperature values are given, dry bulb temperature, and one more time I will see the question, and the wet bulb temperature. Okay, wet bulb temperature. So these are the given information, given data. Okay, these are the given information and given data. Okay, 1 minute. Given data. Okay, so what is the information given? The dry bulb temperature is given as 30 degrees Celsius. Okay, the dry bulb temperature is given as 30 degrees Celsius. So this is the value of dry bulb temperature, and I am representing the wet bulb temperature by T dash, that is 18 degrees Celsius. So the value of the saturation pressure is given corresponding to this. Okay, corresponding to all these factors, and let it be represented by the corresponding to dry bulb temperature, that will provide you the PVS. Okay, and this will provide you P dash V. Okay, so now in this question the head is given as 756 mm of mercury head. So how to calculate the total pressure? So P is equal to rho GH. Okay, P is equal to rho GH. So density of mercury is 13.6 times heavier than water. So G, and this is 9.81 and this is 756 mm. So convert into the meters. Okay, convert into the meters. So 13.6 into 9.81 into 756. So this is coming out as 100,862.49. Okay, so we will check the units. What is the unit? Density unit are in kg per meter cube. Okay, acceleration due to gravity meter per second square. Okay, head it is in meters. Okay, so meter square meter cube, this will get cancelled out. So kg per meter second square. So actually generally we are observing the pressures in terms of Pascal, kilopascal, megapascal, bar in these unit. Okay, so now how to convert in these forms? So let us see. Force is equal to mass into acceleration. So force is equal to Newton, this is kg, this is meter per second square. Okay, so kg per second square is equal to Newton per meter. So kg per second square is equal to Newton per meter. So it is converted into Newton per meter divided by meter. So it is converted into Newton per meter square, and this will become Pascal. Okay, this will become Pascal. It means the unit of this factor is in Pascal. Okay, so now if you want the values in bar, because the pressures, saturation pressures are given corresponding to dry bulb and wet bulb temperature are in terms of bar. So therefore divided with 10 raised to power 5. Okay, so it will become 1.00862 bar. Okay, so this will become this much amount of pressure. Okay, so now in this case the dry bulb temperature, wet bulb temperature and the saturation pressure corresponding to this dry and wet bulb temperature are given. Okay, so now how to find out all the other factors and all like your specific humidity, relative humidity, and so many factors they can ask. Okay, so now first I want to discuss. Okay, first I want to discuss the different parameters. Okay, what are the different parameters? Like this, see it, like your specific humidity. Okay, like your specific humidity. So what do you mean by specific humidity? Specific humidity is defined as the ratio of mass of water vapor per kg of dry air. Okay, or if the values of mass are not given, then you can calculate by using this 0.622 PV upon P minus PV. So in your GATE exam, so many number of times they have asked the question directly on the specific humidity. Next, specific humidity, or it is also called as humidity ratio. Okay, it is also called as humidity ratio. Okay, humidity ratio. Clear? Next is your relative humidity. Relative humidity is equal to mv upon mvs, or you can calculate with the help of this factor also, pv upon pvs. Okay, in the previous questions also, objective part, I have already discussed that relative humidity indicates indirectly the moisture absorption capacity of the present air, and the specific humidity indicates the actual amount of water vapor present in the system. Okay, then dry bulb temperature, the temperature of moist air. Okay, temperature of moist air, and the wet bulb temperature, whose bulb is covered with wet cloth. Okay, now with respect to numerical point of view, next factor is your degree of saturation, and degree of saturation is omega upon omega s, or pv upon pvs into p minus pvs upon p minus pv. Okay, so this is your percent humidity. Okay, this is your percent humidity or degree of saturation. So please remember the names. Okay, please remember the names. Okay, of all these factor. Clear? Of all these factor, please remember the names, omega upon omega s. Okay, specific humidity, relative humidity, degree of saturation. Then enthalpy of moist air. Enthalpy of moist air. So 1.005 T plus omega. This is 2500 plus 1.88 T. So by using this, you can calculate the values of the specific enthalpy of the moist air. And specific enthalpy of the moist air. Clear? So now the next and the last thing is your Abjon formula, and it is used to calculate the partial pressure of water vapor. So 1.8 P. Okay, we will discuss in this PV is equal to P dash V minus 1.8 P into T minus T dash upon 2700. Okay, so now if you will observe carefully, so the partial pressure of water vapor can be calculated by two ways. Okay, not two ways, sorry, partial pressure of water vapor can be calculated by four ways. Okay, if you will observe carefully all these factors, in some question they will provide you the data corresponding to dry bulb temperature, wet bulb temperature. In some question they will provide you the data of specific humidity. In some question they will provide the data of relative humidity. In some question they will provide the data of percentage humidity or degree of saturation. Okay, so in this manner you can calculate the values of all these factors. Okay, so now what are the notations meaning? Notations are T is the representation of your dry bulb temperature, T dash is the representation of wet bulb temperature, and corresponding to this you will get the values of dew point temperature. Okay, corresponding to this you will get the values of dew point temperature. Clear? And corresponding to this, the saturation pressure will provide you the value of wet bulb temperature. Okay, and this is corresponding to the PVS. Okay, and P is the total pressure if not given, then taken as atmospheric pressure. But in this question, if you are able to remember, in this question they have given 756 mm of mercury head. Okay, what is the meaning of that? Meaning is ki the values of the pressure are given, total pressure is given in the question. If not given, in that case you can solve the question by assuming atmospheric pressure. Okay, so now we will deal with this question. Okay, now we will deal with this question, and let us see. So now we will find out the different factors. Okay, so what is the first factor? First you have to find out the PV. How to find out PV? By using Abjon formula. okay, by using F-John formula upon 2700. Okay, so what is the value of P dash V? P dash V is the saturation pressure corresponding to wet bulb temperature. So 0.02062 bar minus 1.8 P. P is the total pressure. So 1.00862. Okay, and this is the dry bulb temperature and this is the wet bulb temperature divided by 2700. Okay, divided by 2700. 1.00862 into 1.8 0.01255 bar. Okay, so this is the value of partial pressure of water vapor. Okay, this is the value of the partial pressure of water vapor, 0.012. Okay, 0.0125126. So if you want to find out the value of the dew point temperature, so dew point temperature is nothing, it is the saturation temperature corresponding to the partial pressure of water vapor. So from the steam table, okay, if this is a subjective type question, in that case they will provide you the steam table. If it is an objective type question, in that case they will provide you some 3-4 temperatures values, okay, and pressure values. Okay, from that you can find out easily the values of the dew point temperature. Okay, if you are able to recall your one question, that is based on the concept of thermostatic expansion valve, which we have already covered, in that case the table is given. So similarly to that, so don't worry about the answer. So they will provide you the table values, so they will provide you the exact pressure values, and corresponding to that they will give you the value of temperature or near about values. So with the help of interpolation you can find out easily. So its value is almost equal to 10.6 degree Celsius. Okay, almost equal to 10.6 degree Celsius temperature. Clear? So now the second part is, there are so many possibilities. First they can ask partial pressure of water vapor for 2 marks, dew point temperature for 2 marks, then specific humidity. So specific humidity you have to remember that it is a dimensionless factor, so P minus PV. Okay, so this is coming out as 0.622 into PV. PV is 0.01255. Okay, 0.01255. So 0.01255. Okay, divided by P. P is the total pressure. So 1.00862, because omega is dimensionless, specific humidity. So please take care of one thing, that both pressure should be are in same unit. Okay, should be in same unit. Okay, so now you will get 7.8. So your value is coming out as 7.83. Okay, 7.83 into 10 raised to power minus 3 kg per kg of dry air. Okay, this is the value of the specific humidity. So approximately you can say that 0.008. Okay, so now the third factor may be relative humidity. So PV upon PVS. So what is the value of PV? 0.01255. We have already calculated. And PVS is corresponding to the dry bulb temperature. PVS is corresponding to the dry bulb temperature, and that is given as 0.04242. Okay, 0.04242. Okay, so you will get the answer in percentage term. Just multiply with 100. So 0.04242. Okay, so 29.58. This is coming out as 29.58%. Okay, 29.58% relative humidity. Okay, next is your next factor we can find out, or in the exam they can ask, that is your that is your degree of saturation. That is your degree of saturation. Okay, so fourth factor, degree of saturation. So this is PV upon PVS into P minus PVS upon P minus PV. Okay, So this is nothing, this is basically a relative humidity. Okay, so 0.2958. okay, so P is the total pressure. P is the total pressure. So what is the value of total pressure? This 1.00862, or either you can see there. So 1.00862 minus PVS 0.04242. okay, so 0.04242, clear, divided by 1.00862 minus PV. PV is 0.01255. okay, so let me calculate the values. 1.00862 minus 0.04242, clear, divided by 1.00862 minus 0.01255, okay, into 0.2958. So this is coming out as 28.69%. okay, approximately the answer is coming out as 28.69%. okay, so these are the values of different possible objective questions. Dew point temperature, partial pressure of water vapor, specific humidity, relative humidity, degree of saturations. okay, next factor they can ask your this enthalpy of moist air. okay, enthalpy of moist air. So we will calculate the enthalpy of moist air also. So 1.005 T plus omega 2500 plus 1.88 T. T is the dry bulb temperature and you have to take in degree Celsius. okay, you have to take in degree Celsius. So 7.83 into 10 is to our minus 3. This is 2500 plus 1.88 into 30. okay, 1.88 into 30. So 1.88 into 30 plus 2500 into 7.83, 10 is to our minus 3 plus 1.005 into 30. So this is coming out as 50.16. okay, so this is coming out as approximately 50.16 kilojoule per kg of dry air. okay, so these are the different factors which they can ask in your exams. okay, and so many number of times in your GATE exam. okay, they have asked, in fact in the engineering services objective part also they have asked these types of question. Now one last possibility is, what is the last possibility? Is your vapor density. Maybe they can ask vapor density. So what is specific humidity? Specific humidity is mass of water vapor per kg of dry air in a given volume. So this is vapor density upon air density. So vapor density is equal to omega times density of air. okay, omega times density of air, clear. So now PV is equal to MRT. So mass upon volume into RT. So P is equal to rho RT. So density is equal to P by RT. Clear? So now we are interested in vapor density, the omega times density of air. So omega into PA upon R of A into capital T. okay. So if you want to find out the partial pressure of dry air, then use the Dalton's law of partial pressure. So total pressure is the summation of partial pressure of dry air and water vapor. So P minus PV. okay, P minus PV, clear. So now see here. So vapor density is coming out as omega times P minus PV, okay, upon R of air into T of air. okay. So what is the value of omega? Specific humidity. Specific humidity is 7.83 into 10 raised to power minus 3. okay, 7.83 into 10 raised to power minus 3. okay. Total pressure is approximately 1.00 something is there, na? 1.00862. okay, so this is 1.00862, but that is in bar. okay, and PV is let me check the values. 0.01255, 0.01255, and these are in bars. okay, so multiply with 10 raised to power 5, clear, multiply with 10 raised to power 5. upon R of air 0.287 into 10 raised to power 3 into this is capital T. Capital T means temperature in Kelvin. Okay, so don't worry about the units, we will check the units, so don't worry about that. So first we will calculate the values. Okay, so 0.01255 into 10 raised to power 5 into 7.83 or 10 raised to power 6 divided by 0.287 and divided by 303. Okay, so this is coming out as 8.96 into 10 raised to power minus 3. Okay, minus 3. Now we will check the unit density mass upon volume. Okay, we will check the units. Omega dimensionless, pressure I have converted in terms of Newton per meter square. Okay, bar I have converted into meter per meter square. R that is in joule per kg Kelvin, capital T it is in Kelvin. Ye cancel. Okay, joule is coming out as Newton meter, so Newton cancel, meter cube this is kg. So this is coming out as kg per meter cube. Okay, kg per meter cube. So this is the answer of this question. So these are the possible objective parts. Okay, so many number of times they have asked. Again in your exam also they will ask only one part out of this for 2 marks. Okay, maybe specific humidity, maybe relative humidity, maybe degree of saturation, maybe enthalpy of moist air, maybe here this factor, that is vapor density. Okay, that is vapor density.